Hello, everyone. Welcome, and thank you for joining us for today's webinar, Made in America, Redefining UAV Production with Additive Manufacturing, brought to you by Commercial UAV News and sponsored by HP Additive Manufacturing Solutions. We have just a few housekeeping notes to go over before we officially get started today. If you need any technical assistance, we first recommend refreshing your browser. If you continue to have technical questions or issues using the On24 platform, please use the Q&A box and I will respond right away. There will be no call-in number for today's session. To connect, you need to have access to either a computer, tablet, or cell phone audio. Everyone has automatically been muted today. If you happen to get disconnected at any time, you can log on again using the instructions provided in your webinar confirmation email. If you continue to have trouble, please email info@commercialuavnews.com and we will respond as soon as we can. For your convenience, everything in the webinar console is fully customizable, so you can move things around, resize the windows, and even turn on captions for this event. At the bottom of your console, you will find a resources box where you can download the slides as well as any additional content for today's presentation. And you can ask a question at any time during the presentation by submitting it through the Q&A box. And we'll do our best to leave time at the end of the session to answer as many questions as time allows. And finally, this webinar will be recorded and you will receive a thank you email with the on-demand materials within 2 business days. And with all of that out of the way, I'd like to hand the webinar over to our moderator today, 3D application engineer at HP, Jared Witkoff. Welcome, Jared.
Thank you. I appreciate the introduction and thank you everybody for your time and attention. So today, we're really happy to host our Made in America Redefining UAV Production with Additive Manufacturing webinar roundtable. Here we're going to be joined by Blue Flight, Firestorm, and Unusual Machines, as well as a representative from HP Additive Manufacturing to show us how US-based UAV manufacturers have strengthened their supply chains and scaled production with additive manufacturing. Today, we're hoping to cover some of the manufacturing in the US, or we're hoping to cover some of the challenges that these teams have overcome in achieving US production and overcoming the restrictions and reservations that they've had in that challenge. We're going to go ahead and kick off with some introductions from both myself and our other HP representative. So as the host mentioned, my name is Jared Witkoff. I'm a 3D application engineer at HP, representing the West region. There we highlight many of our customer needs and introduce people to additive manufacturing, both from incumbent technologies as well as traditional manufacturing applications. With that, I'd like to also hand it over to Emily Levin to introduce herself as well before we jump into our guests from Blue Flight, Firestorm, and Unusual Machines.
Thank you, Jared. My name's Emily Levin. I'm an application engineer at HP. My background is actually in materials science. And so I have some deep knowledge of the materials and inner workings of the printer, and I work with our customers on their applications. So as an application engineer, we focus in HP on a number of different industries, and I have a lot of focus in drones because of some of the advancements we've been able to do that have been really beneficial to the area, which we'll hear about today. So for drones focused questions, I'll be able to kind of speak to what HP is doing in that space.
Awesome. From that, we're going to hand it over to Blue Fight. James, go ahead.
Yeah, thanks, Jared. So my name is James McLaren. I'm the co-founder CTO of Blue Flight. My background is actually 12 years in the auto industry, been doing UAS for about 7 years. We are located in Michigan, and we are a full stack OEM provider of the technologies. So our main customers are the Part 135 air carriers of the world. So you can think of Drone Up and UPS as some examples. We have been on this mission over the last few years to vertically sort of integrate and bring things in-house. Part of the reason for that is being an OEM. It's a bit of a challenge from a regulatory point of view to meet the needs of many different customers. So the ideas of having additive manufacturing and some of the other things we'll talk about today really enable us to be an OEM for a lot of different customers and not just focus on one. We also have a subsidiary called Darkflight, where we focus very heavily on the military space and the whole gambit of things that come along with that. So thanks for having me, Jared.
Awesome. Thank you so much for the introduction. Next, we're going to hand it over to Andrew from Unusual Machines.
Hey, everyone. I'm Drew Camden from Unusual Machines. I'm the COO. I also have a background in automotive, but I've been in the drone industry for 7 or 8 years. Started on the FPV side of things, which are the really fun, fast drones. With one of the brands that's now under Unusual Machines now, Rotor Riot, we've been building FPV drones in America since 2019, and now we are expanding to make the parts domestically as well, which is really exciting, not just for our own drones, but also as a tier 1 supplier to other drone manufacturers. So we're doing electronics in the form of flight controllers and ESCs, some analog cameras, but probably what I'm most excited about nowadays is our motor factory, which is coming online. Additive has been part of our systems since the beginning, so looking forward to getting into how we've used it in FPV so far and how we expect to continue to grow it as part of our business.
Awesome. Thanks, Andrew. Really appreciate that introduction. And finally, we're going to hand it over to Ian from Firestorm.
Yeah, hey everybody. First off, happy to be here, and we're really excited for the audience that we have and my co-speakers here. So Ian Musias, co-founder and CTO of Firestorm. We started out of the onset of the war in Ukraine, where we had the insight that from our experiences as the U.S. military in different places around the world, drones were going to become a bigger and bigger portion of the fight. We wanted to focus on fixed wing UAS initially, but have expanded into multi-rotor and other domains. We really look at it as creating a modular platform that can change over time and adapt to everything that's going on in the battlefield. Our experience is that if you have a fixed system that is hard to integrate with and modify payloads, change in and out payloads, that system will be sitting in hangars and will not be used when the fight starts. So we really wanted to kind of be the antithesis of that. And so we started it there. We've expanded to having expeditionary manufacturing, where we take HP's 5600 system and basically send that anywhere in the world in a couple of connexes that expand out and create a really usable, workable, high volume manufacturing facility that we can set up in less than 24 hours. So that's us. We are a partner and integrate first company. So we really want to work with everyone who creates US made parts and components and subassemblies. So we really look forward to working with many people around the audience and abroad.
Awesome. Thank you so much, Ian, for the introduction. So with that out of the way, we're going to go ahead and jump right into the roundtable questions. So we have some seated questions, but please, as you think about it, fill that Q&A box with some questions, and we'll try to get to those at the end of our roundtable. So jumping into the roundtable, I'm going to go ahead and kick it off with you, James. What are some of the challenges before adopting additive manufacturing that you faced in this space?
Well, in the beginning, we thought it would be a really great idea to be an OEM only and not be an operator. We quickly learned how difficult that could be because everybody wants something different. This customer wants, Ian really speaks to my heart. This customer wants a different payload, or they want a different camera, or they want a different radio, they want a different antenna. So yes, the lightest, most mass efficient way to make an aircraft is to use composites. But by the time you tool everything and then tool it again and tool it again and tool it again to be an OEM, it's really, really hard. So we made the conscious decision that we knew we would end up being slightly heavier, for example, than we could if it was fully composites, to move to AM, to additive manufacturing, and specifically MJF, for like the nails, the nose cone, the tail cone, and the areas where all the avionics live, and even the landing gear, because everybody wants different landing gear. So that was what really drove us, that we sell to 10 different people that want 10 different things. And the only way that we could really survive being a small company and a startup trying to build an aircraft was to move to additive manufacturing. So that was the big sort of push for us to move into it.
Awesome. Yeah, such a good point with that digital manufacturing, that agility that you could achieve, created that frustration in the more traditional spaces. Andrew, do you have anything to add on to that?
Well, on the consumer side, it was pretty similar. I mean, I go back all the way to 2019 when we were just starting to put drones together in Orlando for the FPV racers and freestylers. I like talking about the action camera. Everyone wants to put a GoPro on their racing drone. Well, what angle do you want to tilt it at, right? Which frame are you using? And then, so if you're going to commit to frame and an angle, you're going to injection mold it. And then right when you get the tooling done, GoPro comes out with the Hero 14 or whatever it is. So by going additive, you can be kind of more just in time, right? And you can be more customizable. It's easy to just add a bunch of variants, different colors, different angles. GoPro comes out with a new camera. Well, maybe you've got 100 parts left over, but it's better than having thousands of parts and a tool that's now going to be obsolete when that camera's phased out. So drones are just a really interesting industry because they move so fast. We like to talk about, feels like 3 months in the drone industry feels like a year anywhere else. And additive just helps you kind of move at that speed that the industry demands.
Awesome. Yeah, such a great point about riding that wave of all the technology, innovation, and development. So you could be in the forefront of that and an integrator, just like how the customer needs it. Ian, anything final to add on?
Yeah, just say when you're at the bleeding edge, it's really hard to use technologies that don't kind of keep up with the evolution of an industry. And we're certainly in there, as you highlight right now. And I think we'll be there for a while. We're not going to move to hard tooling for really any of our parts for the foreseeable future. We just find that the price point is there for us. We're not really sacrificing on weight. So why would we move to another technology at the moment? So we love it. We're here to stay.
That's awesome to hear. And Emily, from more of your general experience on dealing with a wider variety of customers, anything else to kind of fill in that, the other team maybe hadn't touched on yet?
Yeah, I think these are really good points. So the customization of using additive manufacturing, the ability to be adaptable is extremely important. I think that when you look at traditional manufacturing, some of the constraints when it comes to, for example, design constraints and the complexity of parts, that's been somewhat limiting, and we can really push the boundaries with additive manufacturing. And in addition, things like the cost or lead time for traditional manufacturing can sometimes be prohibitive of innovation, especially for people getting started. And then we'll talk today about all the way from those initial stages all the way through production, and being able to just be really agile with additive.
That's awesome. That's awesome. Cool. So jumping on to our next question, I'm going to kind of flip the order on how we ask this, but even though it's harder to source some of the things, or the cost target might be more expensive, what are some of the benefits of manufacturing in the U.S.? Ian, do you have anything to add on that?
Yeah, absolutely. Well, so we're kind of forced to manufacture in the U.S., as a defense producer. But even if we weren't, right, that was our ethos as a company starting out, is we wanted to make as much of the aircraft in the U.S. as possible. And obviously, with the NDA compliance, there are countries that we literally cannot do business with, not that we would anyway. We can obviously leverage componentry from other countries that are allies and that are safe to source from. But really, we wanted to be that America first kind of manufacturing company. And so being able to use that, for all of our basically aerostructure parts, all being polymer AM, we just think is a very special thing. And now, today we use contract manufacturer service bureaus that, the HP kind of network that has been really wonderful, mainly in the US, but there are expansion opportunities as well and other, safe places to source from. So we see it expanding over time, but certainly right now, we can manufacture all of our critical structural parts and really have no issues at all sourcing from that side of things. And as I kind of mentioned in my prior comment, we haven't had to move to any sort of hard tooling and have any of those types of delays. So we really love the kind of unbounded capabilities that MJF gives you, and how you can kind of open your engineers' minds to create really, complex surfacing and structures. So yeah, we're happy with MJF, and happy to not be moving to tooling quite yet.
That's awesome. Andrew, do you have anything to add on that, especially from more the consumer space?
Well, I mean, we're actually just now starting to get into domestic injection molding, and I got to say it's pretty nice to be able to drive 40 minutes to see to see the facility and meet with the people, rather than maybe have to take a 16-hour plane ride. Um, and there's also just a sense of security, right? We're America first, domestic. You can feel more better about where your data is going and who you're working with.
Absolutely. And James, you kind of sit on both sides with, the two companies that you represent. How is it in terms of the benefits of manufacturing, both from that kind of government side of things as well as the consumer side of things?
Yeah, I mean, I'll just add on to what the other folks said. The convenience can't be underestimated. The language can't be underestimated. The security can't be. I mean, we almost make our aircraft completely in North America, which is amazing. But what's interesting on the defense side, it's a no-brainer, right? NDAA compliance, all its country of origin, all these sort of things that are required. But we also sell to operators who sell to enormous billion-dollar companies. And it has become sort of the de facto standard that they say, well, we're going to do the same. We're not in defense. We don't care if we're in defense or not, but we still want NDAA compliance. We want all these sort of things. So when it comes down to selling to big Part 135 operators and through them to their customers, it's almost all kind of fallen into, where is this made? How is it protected? How is it safe? What does the supply chain security look like? Which is another big piece of the puzzle. Like, say I choose your aircraft and then I can't buy one little widget in 4 months. That takes the whole production down, right? So we as a company on both sides of the house have just decided that we want to be the owners of our own destiny, which is just rapidly happening in this industry anyways. So it's not just defense that we see it pretty much across the board. It's the same song and dance, basically.
Yeah, that's a really interesting point, and how it's just kind of becoming that standard for the adoption in general. So excellent answer. And Emily, from some of the other customer standpoint, anything else to add?
Yeah, I think we've had this drive towards local manufacturing. You support local companies, it creates jobs, it gives you a lot of control over the environment, not to mention things like the IP and the security. And then, we see it in some cases it's required, but in some cases it's just a preference, but we're able to fill that need. And I think, yes, so there's in some cases also incentives for producing locally. So we've seen, some changes to tax law and things like that help with bringing on new equipment, doing research in the U.S. That all incentivizes local manufacturing.
Yeah,
that's awesome.
Could I add one more thing? I think it's worth mentioning is, and maybe we're sort of unique in this vantage point. So, right, we sell it to the Part 135, I keep saying, but our customers are the big air carriers, right? They have the big Part 135, it's this big sort of, look at us. But you have to have a CMD 44-7 aircraft. And for the people who don't know what that means, is it's 5,000-10,000 pages of documentation to the FAA, down to every firmware, every version, everything that you can possibly imagine, down to where the screws are manufactured. And once you go through that process, which my entire company is consumed by this FAA certification currently, it's hard to go back and say, well, that was great, we did all that, but now I can't buy that and I have to start over. So the security of being able to source things into the future has a huge impact on the longevity of, like, Blue Flight, for example, that I did all this, I spent millions of dollars, I've certified this aircraft, but I don't have security of my supply chain. And so if you would say, like, what keeps me up at night, that's the big piece of the puzzle, that I can still make these in a year under my FAA certification. So I just wanted to add that piece.
No, that's such an excellent point of that, just trust that you're going to be able to do things the same way to meet the regulations, because it's a lot of work to go through that, and to miss out or to have to redo it can be detrimental, especially for companies that are growing and expanding and trying to be as lean as possible. So excellent. Appreciate that. If you don't mind me just
adding one quick thing,
I
think doing, bringing it domestic also means we're doing a lot more. I think all of our companies are doing more in-house, which, I mean, it feels really great to be creating all these jobs, like Emily mentioned. But then it also just means that, hey, like what James was saying about having the confidence that will be resilient. Like when you're doing it yourself, when you're building your own team, you know that there's no one to blame but yourself if you're not set up for success. So it feels really good to have control over that aspect of the business.
Yeah, exactly. And that kind of leads us into our next question too. So Andrew, I'm going to kind of ping that off you. If, so there's all these great things of manufacturing in the US, but, you want to manufacture there. What are some of the challenges that you face in doing that? Obviously, there's robust, resilient supply chains of old that have been used, but you don't get all those benefits. Now we're here, we want to do this. There's maybe some requirements to do this, but what are some of the challenges?
I think a challenge is just accepting the difficulty. I mean, if any incarnations of our work, in the past, if you've sourced things from China, you'll know it's just really easy to work there. They do a great job, and it's easy to find multiple suppliers and kind of get the prices competing against each other. So you just have to get over that acceptance barrier and say, okay, we're going to do it here. It is possible. It's going to take a little bit more work. I'm not going to be able to find 5 options in an afternoon. It's going to take a week or 2 to find 3. And there's going to be, huge swings in what you find in terms of pricing. And, we just go in with, here's the pricing that, we're used to from what we, have done overseas. This is what our customers are expecting. And we just decide, okay, what increase is acceptable, and start there and work backwards and just work through all the trade-offs and what's even available. And then just determining also, I think it was Ian that mentioned, you're still going to have to do some sourcing from allied countries, and that's great. It's fine. We just want to find trusted partners and get our subcomponents in-house and make sure we knock out final assembly.
Awesome. James, how about you? What are some of the challenges that you faced in, domesticating or having the domestic manufacturing?
To be honest, there are a lot of things that are very doable. I'm all about America first and all these sort of things, but reality and being a business and keeping the lights on sometimes not completely supportive of sourcing some things. But there are some things that are extremely hard. A great example is historically we've flown folding beautiful 24-inch carbon fiber propellers from China. I can buy a fully assembled with a hub even with tariffs for like $400, $500. I have quotes in this country that range from $30, $40, $50, $75,000 for tooling, which I can wrap my head around, and then $1,500 a blade, to $2,000 a blade, to $1,000 a blade. So if you look at my aircraft, which is in the upper right of this picture, right, 90% of that, I internally or in this country or in North America, I can be extremely competitive, extremely. But when it comes to things like carbon fiber propellers, which is a highly engineered, and let's be honest, and I'm not afraid to say this, these propellers are the best. I mean, they're amazing. Like if you really look at how they're made and the thought, it's wild. It's super impressive. There are 1, 2, 3 things like that, at least for my size of aircraft, that I don't know how to replicate in this country. I could go to Europe as well. So I could go to like Mejlik in Europe and in the Czech Republic, and I can get a propeller. But we're sort of drunk on these Chinese propellers because they're that good. And we haven't cracked, as a company, we haven't cracked that nut. So if I were to summarize, my biggest sourcing problem is friggin' propellers.
Yeah. No, and I think that's an excellent point of, there's so much that you want to do, but, in that challenge there's certain elements, there's certain key components that we just haven't quite made that edge. But, this also leads to opportunities. Ian, do you want to round out the answer on this one? Anything else to add from your side?
Yeah, I'll just take the baton from the opportunity side of things. I think that's the really exciting part is there all these different subsystems that are needed across the different, rotorcraft, larger multi-rotors, and fixed wings. And so what I think is going to continue to happen is I see new startup, almost every day it seems, that's looking at some portion of the picture and saying, hey, I can do that component. That's interesting. And I can make money on it. And, to the point of basically, sometimes the engineering is just so good, the manufacturing is so good somewhere else that it's hard to even replicate. And that's where I think, there's always opportunity in those areas. And so I do think we'll see a lot more competition come in, but I also think the US, we have to keep pushing advanced manufacturing because that's our kind of our in. We can kind of leapfrog if we go after just fully advanced manufacturing, additive. We have to basically work around our labor costs here and still produce really good parts. And that's a difficult process or a difficult problem, but it is one that's solvable.
Yeah. No,
And your
excellent
baby agrees
answer.
with me.
And I think this kind of leads into our next question too, of like, in your case, obviously with these challenges that you mentioned, how did you solve these challenges? But I think I'm going to expand that question into what is that kind of call for action that you'd like to see, that potential opportunity as you described? Because obviously, James, you put it great of like these blades are excellent. There's no competition. So if a company came out and innovated in a way, and Ian, I think you mentioned it well, sidestepped that labor limitation or the traditional kind of expertise that maybe we haven't developed, what could it be? So, Ian, if you want to just kind of follow on, because you already kind of half answered, from that proposal, how did you solve maybe some of the problems that you had in adopting US manufacturing? And then what is your call to action?
Yeah, I think our call to action is that there is this renaissance going on right now. I saw a post recently on LinkedIn that was talking about, the amount of new, CNC kind of manufacturers in the US and how, there is a momentum that we have at the moment, and we have to keep fostering that. And what we really have to do if we want to invest in the US and as companies that are really kind of feeding off of this momentum and this renaissance, we have to leverage these companies. We have to give these companies contracts. We have to buy parts from these companies. Like everything will improve, and you'll have this beneficial snowball effect or this flywheel effect as long as we are sort of helping each other out. So the U.S. Does better, and for ourselves, for our country, for our military, on our side of things, if we are investing in companies in the U.S. And kind of perpetuating that. And so the call to action is just, I want people to keep kind of investing in themselves, investing in the US. You have those ideas, you see that there's opportunity. I mean, what we are kind of fostering is this like ecosystem built around our aerial platforms. Our aerial platform is just the vessel, just the vehicle. And really it's about what are the capabilities that we can add on to our vehicle, whether that's cameras or, electronics or propulsion systems. I mean, heck, even structural parts, like we will look at anything that folks have that they think could be, an X factor in the UAS space. So really I want to kind of like a heartfelt reach out to everyone who's listening and that will listen to this is just, keep that drive, hit up companies like ours that are doing things and have momentum to potentially highlight whatever you're doing, and look for those opportunities everywhere you can, because there are tons of opportunities out there. And our country has a wealth of talented engineers and entrepreneurs, and we just need to keep that forward momentum and look for opportunities everywhere they may come.
Awesome answer. Appreciate that. And James, you kind of gave a very specific problem, and maybe there's not a solution to that problem yet, but in terms of the breadth of challenges of domestic manufacturing, what are some of the ways that you've overcome those challenges? And then, also if you have that kind of call to action or, things that you'd like to see also coming down that pipeline that could help enable more or more easily adoption of this, what would they be?
Yeah, I would actually just add that I wholeheartedly agree with Ian. I mean, so the propeller was a really good example. Like we're in the trenches on this, right? And we go to the people here who want to bring back manufacturing and do amazing things here in this country and make things that are so finely engineered like this. what I've been pretty successful at is taking these things and saying, let's figure this out. So, on the propeller front, we have 2 conversations going where we want to figure out how can we do this? How can we be competitive? And convincing the people that we can compete, or the people who have the know-how and the skills, especially on the propellers, for example, to compete, down to, electron microscope SEMing parts and understanding how all these things are made. And we've had really good luck, I guess, in summary, of convincing people that we can compete on these really challenging, cost-efficient, highly engineered components here in this country. Can we get there? I hope so. I'm going to push as hard as I can because these are kind of the open items for me. But I don't know if that answers your question directly, but we've had good success on the challenging parts, riling the troops and getting them going, and we can do this. Let's figure it out. And I'm just praying that we can get there. I believe we can get there, but we're pushing hard from our side.
Now that makes a lot of sense. And it's kind of finding the right partnerships, finding the right people that are willing to kind of do that investment time and recognize that they're overcoming a challenge. It's not, kind of maybe so cost driven that it's we're trying to get the most cost effective product today. It's how do we create a solution that's scalable to the future that incorporates these. I really like that answer. And then Andrew, anything else to kind of add up from more of the consumer FPV space? How do you see that?
I think when I talk to people about making things in the States, a lot of times the first thing they'll say is, "Oh, well, you'll never be able to compete with Chinese pricing." And my response is always, "Well, not with that attitude." It's difficult to compete, but if you believe you can do it, you commit to doing it, it is possible. I mean, there are going to be trade-offs. You might need to invest more upfront in automation to, be competitive with overseas labor rates. You might need to rethink how something has been designed, as it's always been designed. And in this case that we're looking at now, there's a CNC feature that adds a ton of machine time, and we just realized, well, wait, what if that was a separate plastic piece because it doesn't need the aluminum strength, right? Maybe we'll do it with additive.
Yeah.
Yeah, I mean, I think it's just set your goal, commit to it, get creative, find the right partners and investors to, we're very fortunate to be in the position we're at, where we've been able to build our factory, our motor factory, in the way that we have, where we're going to do with 7 people what it would take maybe 30 overseas, right?
No, I think those are all excellent answers. And Emily, anything to kind of round off from some of the broader customer experience that you've had?
Yeah, so I think some of the challenges for our customers in terms of manufacturing locally with traditional manufacturing come down to it being expensive. There maybe aren't many options or have long lead times, varying quality. And that's where MJF kind of comes in, is that you have this platform where you can create really high quality parts. They're distributed, so you can manufacture locally or in-house. And yeah, we'll talk a lot more about the value of that, but I think that moving to additive manufacturing, being able to take advantage of the ecosystem that we have there, the design complexity, solves a lot of the local manufacturing holdups.
Awesome. Yeah, and I think that's a good segue to our next question of, why did you adopt MJF? And we're going to go ahead and start with you, because you kind of called it out in your introduction and throughout some of your comments, especially with your kind of, distributed manufacturing solutions and stuff like that. So why did you choose MJF, and how has that kind of enabled success in your business?
Yeah, so during the pandemic, I actually had a side hustle company where we saw the need for PPE in the US and saw that we couldn't actually, get the supplies that we needed, mostly coming from China. So was able to start up kind of a side hustle company, leveraging the contract manufacturers and service bureaus in the HP network, and really knew or kind of saw the light through that process of scaling through millions of parts produced. So these were face shield frames that could be variably sized, and then basically just die cut face shield that would go on the frames. And so scaled through, again, millions of parts, saw that it was with leveraging the network in the US and these folks that also at the time really needed business, which was really great. So everyone was really looking forward to working. And so that scale opportunity there without really having capital expenses, leveraging a network, was very interesting. So I knew I wanted to replicate that again with Firestorm, which is, hey, we're a startup. We don't have all the money in the world. But we can pay a little bit more for parts from contract manufacturers and service bureaus and scale our business without having to go immediately to machine acquisition, which is a really nice path. Now we've come a long way, and we've acquired quite a few machines, and we'll continue to do so. And really, the process is, one of the most mature. I've been kind of spoiled through Additive. Honestly, I hardly have ever used any FDM. I've used DLP, DMLS, all kinds of sexy processes. But I truly love MJF because it does kind of allow you to not really have to think as much. I mean, there are obviously caveats to every process, but I really like how I'm not worried about what does my support structure look like for this, or is that going to be printable? Truly with MJF, most everything is printable, and obviously we're pushing the bounds of like how thin can we get surfaces and portions of our aircraft to lightweight, but we're unbounded, right, by the types of infills that we can do. As long as we can get the powder out of things, the complexity of parts can just be very extreme, and allows us not be sort of cornered into making decisions because of the process limitations, but rather really just expand out the possibilities to engineers and designers to create really, exciting components.
That's awesome. No, I appreciate that answer. And Andrew, would you like to follow up on that?
The honest answer for why we started using MJF is just because it's really cool. And we just wanted to explore a unique American technology. We had already been using FDM. It was going fine. Now, the truth is we explored it and we found that, hey, there's this, the drone that's being shown now, those ducts, right? We make a lot of those ducts. We're making all of them with FDM. I mean, it's getting to that point where you would start looking at injection molding, and we did. And we're like, well, the volume's still not quite there. I mean, we could do it, right? But then we look at MJF, and now you're paying for the volume rather than the part. And then you think, okay, well, how many of these ducts can we cram into this box? Are we there yet? Well, what else can we do? Okay, well, they're shaped like rings. So what about that antenna holder? Can we put that inside the ring? Can we do all this? Can we get creative with how we nest everything? And rather than printing one duct at a time, one antenna holder at a time, print 100 drones worth of all of that whole kit all at once. Mm-hmm. So there is a cost saving, and kind of a more of a repeatability in terms of quality and surface finish. So it really made sense for us to do it. But if the question is why did you do it? It was just because we just made the decision. Just kind of going back to that, what's that call to action? It's like, hey, here's a cool American company making a cool new technology. Let's really like put the time in to see if we can find a fit for it. And we did, and we're happy we did. But it could have been easy to just be like, nah, what we're doing is fine, right? We could have just not. Yeah. But I'm happy.
That's a great answer of like that dual winged of like, yes, there's the cost efficiency, there's the scalability, the repeatability, all those spec sheet things, but also kind of the direction that you want to take this whole global solution. And, kind of meeting back to like, how do you solve these challenges, or how do you overcome it? You do it. And the more you do it, the easier it gets to do it in the future. If you look at everything as an insurmountable problem, you're never going to accomplish it. But just by going forward and taking that advantage, and then you work on it, you refine, and you have that edge, and then you become that industry leader yourself. So that's excellent. I really like that answer. James, do you have anything else to add?
Of course, I think this is a great topic. So for us, yes, all the cool things, we love it. Like we tried them all, and MGF is where we settled. But what we need is repeatability. So I'm going to belabor the point a bit, but through the FAA certification process, we define with a drawing number and a revision, the build volume. It cannot change. The prints have to be printed in the same orientation. And then once you do this, that you have the build volume defined, it can't change. It's got to be a 5620. It's got to be this firmware. It's got to be this lot of powder. I can then make those wherever I want. So that picture on the screen right now, that's in Saudi Arabia. I have drones in Australia. I have drones in Indonesia. And they're not tiny, right? They're almost 2 meters square. So shipping a crate around like that is very, very expensive. So as long as we can control the process and we have the right printers and powders where we need, we can ship a box that's like this big with all the bits, print in country, and like we're doing this in Australia, and then assemble the drones there. So it has a lot of advantages as well. So for us, it was a real production, repeatable tool. Beyond all the other cool things that came along with it was what really drove us.
Yeah, excellent answer. I like that scalability and that abstractability where, as long as you've defined something, that digital manufacturing kind of process of operations, you could then enable that wherever you have these tools. And there's no need to worry about kind of specific labor skills or quality there because you've already, predefined it up front. Emily, anything else to add from kind of a more general customer standpoint that why they've adopted MJF? We obviously have covered cost and repeatability or things like that. Anything else that kind of strikes your mind?
Yeah. So taking a step back, we have customers in the drone industry who are producing parts anywhere from components to a full drone, the frame, the fuselage, wings, landing gears, and at pretty large scale, right? You guys have mentioned over 2-meter wingspans on some of these UAVs. And then what do they need to do that? So we're also talking about not just prototyping, but full production. So from a prototyping standpoint, of course, you can produce these one-off parts. And that's really difficult to do with some other traditional technologies, especially we've talked about injection molding, where you kind of have to think about scale. But this technology, MJF, you can be producing these repeatable, robust parts anywhere from the 1 to into the thousands or 10,000s range, right? So it's a very scalable technology for production, and it gives you something that's more durable than something like FDM. We've seen examples where components printed in FDM, they make good looks like prototypes, but they'll break during like a flight test. Whereas a lot of people will move to MJF because of the really high quality of the parts. Again, what we see is something like strength to weight ratio is extremely important for UAVs. And this is a technology where we've been able to get extremely thin walls and really reduce the amount of material required because of the strength of those parts. The other thing that I would say is people adopt MJF also because it lowers the barrier to production, right? If you can have an idea, you can CAD it, you can send it to a service bureau and get one part made, and you can scale that all the way through production in the same material with the same process.
Awesome. Excellent answer. So kind of diving in a little bit, we've already touched somewhat on the general answer of why have you adopted MJF, but maybe in a little bit more of a specific answer, what have you been able to achieve with MJF and how has it been able to elevate your work? How has it kind of transitioned maybe from either other additive manufacturing or traditional manufacturing? Where have you seen that kind of wow moment where you're like, oh wow, we could enable things that were otherwise impossible, or we're able to scale in a way? Andrew, we'll go ahead and start with you. You kind of had a specific example before, but we'll see if we could dig a little deeper.
Well, in terms of elevating, something that was fun for us was that on this Skylight drone that we sell to consumers, we had been selling with FDM parts. Consumers, our FPV consumers, are used to seeing layer lines. Like the FPV drone user, they're more cost conscious than anything else. So they're used to seeing raw CNC carbon fiber, exposed bolts, and layer lines. And then we looked at this, MJF as an alternative to FDM. Said, okay, well, it's actually gonna, be a cost saver for us. We just have to produce in higher volumes. And this will be kind of a cool thing to show to the customers that are already used to seeing kind of the raw manufactured look. And I mean, I really like the way MJF looks straight out of the printer with kind of that called a velour finish. And I think it's really awesome, all the post processing that you can do with vapor smoothing and painting and all that. I mean, you can get like a Class A surface that's great. And I think there will be a product at some point where, you know, we'll explore more of that. But, you know, right now getting to expose kind of our consumer base to this technology has been kind of an exciting thing.
Awesome. And I do quote you on that velour surface of our MJF when customers ask, what does it look like? I go, well, one customer had that.
Velvet. It's velvet.
It's like velvet, yeah.
Exactly. I like it. I like it. Ian, do you have anything to add on that? You know, how MJF has enabled you to elevate your application?
Yeah, I mean, it allows you to think about the problem differently. You create structures, fixtures, fasteners, print in place connections that are really specialized that you wouldn't be able to do with other processes. So from that perspective, it's really great. You're talking to a bunch of aerospace companies here. Obviously, we care about aerodynamics. So the ability for our aerodynamicists to basically be able to tweak tons of different parameters with, you know, how a wing joins a fuselage or whatnot. Like right now, we're a fairly simple tube and wing aircraft, and that's for, you know, some reasons it looks kind of traditional, but we're actually able to pack really well with that type of structure. We're moving away from that and more into kind of a more blended wing body type of vehicle, and how our, you know, stabilizers connect to the fuselage, et cetera. So, you know, going forward, we will look like we're leveraging kind of the surfacing and complexity benefits of the process. But truly, even today, there's a lot that we're doing with packing densities with a kind of more, you know, tube and wing looking aircraft. So, you know, it's great to have the flexibility for our engineers from a design standpoint. But it also is great from a performance standpoint because in the end, you get better aerodynamics, lower drag, and, you know, as Drew talked about, you can go to different post-processing that also decreases things like skin friction drag, which you also care a lot about when, you know, maybe the standard surface is, yeah, beautiful in its own right, but maybe you want things a bit smoother depending on your flight envelope.
Awesome. Yeah, appreciate that answer. And then James, do you have anything to add on that from your experience?
For sure, there's really two kind of wow, beyond all the amazing things that we've done over the years, there's kind of really two awesome wow sort of situations going on for us. Again, I'll reference the picture in the screen. That aircraft to finish traditionally when we weren't using something that could come out like MJF, it takes about 600 grams of paint just to finish it and make it look like something that, you know, I want to send out of my facility. So the idea of vapor smoothing with the white nylons coming out of HP is super exciting for us, and we really want to do that too. I mean, 600 grams for us will be huge. I know it is a 25 kilogram aircraft, but that's a lot in paint. So some of these newer things of vapor smoothing and white nylons and stuff like that are really, really exciting for us. The other thing that I think is super wow that's just coming down the pike is augmenting MJF with carbon inserts. There's some pretty cool tech out there that we're pushing with HP and some other folks where that entire tilt arm, so that arm is actually, we're a tilt rotor, so the arm in the picture actually rotates. That aluminum part, the carbon fiber tube and the aluminum insert that goes in the aircraft, we will print that and insert a carbon fixture inside. So we can completely get rid of the round sort of shape of that tube and make it an airfoil, for example, to make it more efficient. So I think for us, it's like taking the amazing base MJF and taking it to a whole nother level and getting rid of paint and making parts simpler with augmenting it with structural carbon fiber.
That's excellent to hear. And, you know, we love it from the HP side too, of how we could work with customers to iterate our own technology and adapt and grow it so it meets these needs. And, you know, that customer feedback and relationship that we have, I think also builds, you know, how MJF can elevate the work, because we could elevate the MJF itself. Emily, do you have anything to add on? I know you have a lot of experience with you know, customers elevating their work and you know, adopting MJF and really achieving wow moments.
Yeah, our drone customers, they've been really able to optimize their designs by using things like design complexity. So for example, you can use computational tools like topology optimization in order to really reduce weight, which depending on your type of application, right, it can let you go further, or maybe use a smaller battery, or have a higher payload, right? So your takeoff weight unloaded is lower. And we're able to do that, like I said, through computational tools, but also through some of the features of the technology. So we have some of the things our drone team has been working on at HP is ultra lightweight wings, through really reducing the skin thickness and then having a more complex pattern that's like a ribbing into the surface that gives it that rigidity, even though we're only printing at a fraction of a millimeter in terms of the skin thickness. And so in one area, they've been able to optimize for their application. And in other areas, we see things like they're able to have this really fast iteration because they have the printing, they can get their parts next day, or at least very quickly compared to traditional manufacturing. And in that way, they're able to do their development so fast, they can be releasing new versions every 3 months. And so always moving faster than the competition there. And doing that in a low cost and effective way.
Awesome. So we got some time for a few more questions in here, and I'm going to modify this next question a little bit to kind of adapt to some of the questions in our Q&A. But Ian, you mentioned this a little bit in the adopting and scaling of 3D printing, and Drew, you also kind of talked about your journey with FDM and to other, but as companies are looking to scale and grow into MJF for these UAVs, or not necessarily in MJF, into scaled manufacturing. What does some of that journey look like from maybe, let's say, a new startup company, someone who has an idea or a spark or an innovation that they want to try to enable, all the way to a fully scaled business? And how do you see them kind of using additive along that way? And like, what are some of the vehicles and vessels that maybe you guys have done through your company's growth, or if you had to do it again, you maybe, with your knowledge now, would have gone there? So James, I'll go ahead and start with you.
Sorry, start with somebody else. I was distracted with something. I'm going to be honest. My apologies.
Drew, go ahead. We'll start with you. You kind of have that great, you've mentioned your journey with FDM and
Sure.
kind of lower cost applications. And so, what would be your kind of roadmap if you could, one, do it again, or two, give the advice to someone, jumping in?
I think my advice would be, FDM is a great place to start for low volume. It's cheap. I mean, you can get a desktop printer, have fun, prototype. Then you go to the other bookend, injection molding. You're making tens or hundreds of thousands of parts per year. I see MJF kind of as that bridge. So I think the journey could look like, you start on FDM, and as you scale up, you'll kind of go through, a point of maybe doing MJF. I mean, if you're going to make 100 parts, just do them on a desktop printer. If you're going to make 1,000 parts, maybe that's going to be kind of challenging. Maybe do that with MJF. And if you start doing 10,000 parts, you should evaluate doing injection molding. So I that's kind of how I see the step function. I think a challenge is, a desktop printer, super cheap. MJF setup, pretty expensive. The nice thing is there's a network of service bureaus or providers that you can work with. So we haven't bought our printer yet. We might. I want one. But we work with Forecast to do a great job. Forecast 3D, and kind of right now with some of our parts, kind of in that sweet spot where, really happy to not have had to do the cash outlay for buying our own printer and staff it and all that, but didn't want to invest in a mold and give up kind of the flexibility on design changes as new requirements come out. Hope that answers the question. Kind of all over the place.
No, that's great. And I think that kind of journey along the way of there's lots of decision points, and there's not necessarily a wrong answer, but you have to kind of dig into it and make it work with you. And like you said, with the contract manufacturers or the service bureaus out there, they can help kind of be the impedance matchers as you're transitioning steps, or as you're thinking about, that kind of try before you buy. And, Ian, we'll hand that over to you, because I think you had the similar experience with the contract manufacturers, especially in your previous, business, and then how you took that into Firestorm.
Yeah, everything's about risk too, right? Like coming from the DLP space, obviously a really kind of fast process as well, but not a level of maturity as far as all the ancillary equipment that is around that process right now. You got photocurables, so you're doing secondary cures, and that can be thermal, or that can be UV, multispectral UV. Like there's just that process continues to evolve, and it's a great process. FDM is obviously, and other toolpath-based processes are extremely slow. One reason why I sort of despise them, no hate, but just it's not my go-to. I like fast processes with high level of detail. And when you look at something like MJF, you have a process that is inherently very high detail. These effectively 2D inkjet heads, very small minimum like voxel size, and so what you can do with that, and the constraints that are sort of released is really special. And then when you're looking at something where you're like, okay, am I going to de-risk this by printing some first parts? Yeah, sure, in FDM, but really, like, sometimes you don't learn what the issues are going to be until you go to some of those processes that do kind of get you into those higher volumes. So we'll go to MJF right out of the gate. Obviously, we have printers now, but sometimes it's a de-risking factor to go there, because you're working with an industrial grade machine with a lot of in situ processing and analytics to tell you what could be going wrong. Whereas if you start with FDM sometimes and do even small batches of parts, things go wrong. You have, one build to the next is going to be pretty wildly different. So we like to obviously, embrace MJF kind of entirely. And you can do so, cost effectively as well by using these folks that we've discussed. And then, yeah, as you start progressing through, look at getting your own machine so you can kind of control more of the QA/QC steps in your full assembly process. But you don't need to go there immediately, which is very nice.
No, I think that's an excellent answer of that kind of scalability and confidence in what you're producing as you get into these higher end tools becomes more and more controlled. And James, I'll swing it over to you to just kind of finish off. And I think you've mentioned some of those aspects of having that fuller control. So we can finish that question, and then I think we might have time for one more question just to round off the end of this panel.
Yeah, for sure. I mean, control and traceability and repeatability is super important. But I think the other thing, we've been so focused on end parts, like we're making parts that are going on an aircraft, for example. But also the timeline of FDM, maybe MJF, and then soft tooling, hard tooling, et cetera. Actually, we make tools with MJF, right? You can make all of your soft tools and do it very fast, where you're not machining it out of aluminum or any sort of metals. So something we really didn't touch on is I think it changes the whole time horizon as well. So maybe it was like 500 parts, big parts made sense to make a metal tool, but maybe now you can make MJF tools or soft tools. Maybe it's 1,000. I think that's a big enabler that people should think about MJF for, is making tools. We cast all of our own lenses in-house, so anything clear, we cast them, and we print our tools and everything we need for that out of MJF. Versus traditional sort of methods. So I think it's important to say that, we've been focused on sort of like end pieces, but it's also interesting to think about the time horizon that MJF could, make tools as well.
Awesome. And Emily, I know you probably have some great stuff to add just from like a whole, segment experience and what you've seen. So go ahead and round off our answer.
Yeah, well, just in the interest of time, as a quick answer, I think one of the challenges to adopting MJF and additive is really kind of mental limitations on what people think you can use it for. So we see a lot of people who have familiarity with other types of additive, like 3D printing, desktop printers, and so they don't understand necessarily all the boundaries that can be pushed by this technology. And so with that, I would just say, if you're going to be at Exponential this next year, come see some of the things that we've been working on. We'll have wing segments, full drones there to check out. And I think the expertise in designed for additive manufacturing and understanding how far we can push the limits. We're doing some of that in-house right now. We'd love to share, but yeah, I think we can go really far with that.
Awesome. Excellent answer. And just as one final thing before Kaylee comes in and tells us that we're out of time, just future, next 3 to 5 years, what's one thing that each of you would like to see in terms of additive in this UAV space? What is your dream? What is your wish list? Just kind of one topic on there. We'll start with you, Ian, and then we'll go to Andrew and then to James.
Yeah, I think materials. I think there's going to be a lot of evolutions of materials. Right now, we go with low cost PA12. It's ubiquitous. We can get it everywhere. It's made by the largest chemical companies in the world, and then obviously produces great parts through HP. So I want to see what kind of the next horizons look like for material properties, because again, that's just going to allow us to decrease weight and improve performance of our aircraft.
Awesome, Drew. You're on mute.
Sorry about that. I don't know. I was going to say the same thing Ian said. Just kind of want to keep seeing the, different variants in the materials. We use a lot of TPU right now. It's awesome. It's like indestructible, but it's flexible, and then there's some of the PA blends that, have that rigidity, but maybe don't have that durability, right? So, I'd love to just see more additive processes that can get to, like aluminum levels of strength. That'd be cool.
Awesome. And James, what's your wish list item in the next 3 to 5 years, if you could see it?
And I know this is a loaded statement, and I know the complexities around this because I've talked to HP, but I'm going to mention Markforged and the continuous fibers. If I could have continuous fibers magically inside my HP parts, which I know is almost technically impossible, I'd be happy as a clam, because that would unlock like literally everything. But yes, I know that is quite a wish, but what they do is pretty awesome on the continuous fiber side, but it's FDM still at the end of the day, right? Yep. So that's my ultimate wish, which I know is impossible, but I always bring it up. So
hey, if there's enough will, there might be a way. But it's great to hear from you guys. We really appreciate the time. So I just want to say thank you once again to the panel. Appreciate you taking the time out of your day to answer these questions. Thank you for the audience. And with that, Kelsey, I'm going to hand it back over to you to conclude.
Excellent. Thank you, Jared. And I just have a few housekeeping notes to go over before we officially close out today. If you could please fill out the short evaluation form that will appear on the webinar console shortly. This will help us better serve your needs in future webinars. And as a reminder, the on-demand materials will be emailed to everyone within 2 business days. And this will include a PDF of the slides as well as the link to the recording of today's presentation. And thank you again to all of our panelists for a great roundtable discussion today. And thank you to all of our attendees for taking the time out of your busy days to join us. This webinar was brought to you by Commercial UAV News and sponsored by HP Additive Manufacturing Solutions. Thank you all and have a great day.
Bye, everybody.
Bye. Thanks.